Hey everyone, welcome back to the channel Code with AKJ. Today is day 18 of solving LeetCode Science 5 challenge, and today's problem is find the highest altitude from prefix sum technique. So the question says there is a biker going on a road trip. The road trip consists of n plus 1 points at different altitudes. The biker starts his trip on point 0 with altitude equals 0. You are given an integer array gain of length n, where gain of I is the net gain in altitude between points I and I plus 1 for all 0 less than equal to I less than equals to n. Return the highest altitude of a point. So today we'll solve a fun and simple problem from the prefix sum technique, that is find the highest altitude. We'll walk through the brute force approach first and then move on to the optimal solution. So let's dive in. So the problem statement says imagine a biker on a road trip starting at an altitude 0. They move through several points and each move has a net gain or loss in altitude given in an array called gain. So our task is to find the highest altitude they reach during the trip. So let's quickly look at an example. So the first example given gain array with -5, 1, 5, 0 and -7. These are different altitudes on this given road trip. So the biker starts at altitude 0 and adjusts based on the values in gain. So the highest altitude reached here is 1. The initial value would be 0, and when we move forward on this given road trip with different altitudes, we'll calculate the net difference between these two altitudes or the points I and I plus 1. We'll get these values, that is 0, -5, -4, 1, 1 and -6. So among all these values, the highest value is 1. So we'll return 1 here. Same goes with the example 2. We have given an gain array with different altitudes at different points in this given road trip, and the altitudes gain between these 2 points I and I plus 1 would be 0, -4, -7, -9, -10, -6, -3 and -1, and among all these values the highest would be 0. So let's start with our brute force approach. In our brute force approach, we'll calculate the altitude at every point and we'll store that particular altitude in one array, and we call that array as a prefix array. So after calculating the altitudes of 2 points I and I plus 1, we'll finally find our maximum altitude net gain from this prefix array. So let's understand this given problem statement with an example here. So in our brute force approach, this is the gain array given, and we'll calculate the difference array or the prefix array, and it can be calculated using the current sum between I and I plus 1. So initially we'll start with altitude 0. So we'll store 0 in our difference array or prefix array here. As we move forward in this given gain array, we'll calculate the sum between these 2 points I and I plus 1. So initially it would be 0, and when we try to add this 0 and the next altitude gain and the next point -5, we'll get -5. Then -5 plus 1 gives us -4. -4 plus 5 will give us 1, and 1 plus 0 will give us 1, and 1 plus -7 will give us -6. So we'll store all these values in our difference array or prefix array, and finally from this given prefix array values we'll find our maximum element by iterating over this prefix sum, or we can use any inbuilt function to find the maximum element from this given array. So in this example our maximum value would be 1. So for this given example our answer would be 1. The time complexity of this approach would be O of n, as we are iterating over our gain array which would be given as an input, and space complexity here would be O of n, as we are storing these values in a extra space prefix sum array. So let's quickly move on to our code. So this is a code for our brute force approach. Here I have taken the vector of int of altitudes to store the altitudes, and initially our current altitude would be 0, as we are starting with a height of 0. So initially we'll push that current altitude in our altitudes array, and we'll iterate over our gain array, and we'll calculate the current altitude by adding with our current element gain of I, and parallelly we'll push that current altitude value in our altitudes vector. So after storing all those altitudes, we'll find our maximum altitude out of this altitudes vector by iterating over this vector altitudes, and we'll update our max altitude variable by comparing it with current value, that is altitude here. And finally, we'll return our max altitude, which would be our answer. So let's quickly run this code. As you can see, it works fine. So let's submit. As you can see, it's successfully accepted. So here we have created an altitudes array to track every point's altitude, and then we iterated over this array to find the maximum altitude. So while this works, it's not the most efficient because we use extra space here. So let's quickly optimize this and not use any external data structure to store any altitudes at each and every point. So in our optimal approach, instead of storing all those altitudes, we can calculate the current altitude on the fly while keeping the track of the maximum. So this reduces our space complexity to O of 1. So let's quickly modify this code and again let's run this code. So here's the code for our optimal approach, where instead of storing all those value in a separate vector, we'll calculate our current max value, that is current max altitude value, and parallelly we'll update our max variable, which would be our highest altitude of a point. So here I have iterated over our gain array. I have calculated the current max at this particular point, and parallelly I have updated my max variable by comparing max variable and current max variable. I have returned the max variable, which would give us the highest altitude of a point. So let's quickly run this code. It's working, so let's submit. As you can see, this approach also works. So here, instead of storing all the altitudes, we directly updated the current altitude and compared it with our maximum variable. So this approach is both time efficient and space efficient. So the time complexity of this approach would be O of n, and space complexity of this approach would be O of 1. Let's quickly analyze the space complexity and time complexity of both the approaches we have discussed. So the brute force approach takes O of n time complexity and O of n space complexity, whereas in our optimal approach, the time complexity was O of n and space complexity is O of 1. Because of the altitudes array, the space complexity of our brute force approach was O of n, and in our optimal solution, we have removed the external vector to store all those altitudes of a given point and reduced our space complexity from O of n to O of 1. And that's it for today. We have learned how to find the highest altitude using both the brute force and optimal approaches. So if you found this video helpful, give it a thumbs up and hit that subscribe button for more daily coding tutorials. I'll see you in the next video. Thank you.